Hello everyone and welcome back to another video, and today we'll be going into SAT Math Lesson 2. And in today's lesson we'll be going over two topics. One is absolute value and the other one is direct and inverse variation. So if you haven't already watched the previous videos, I really recommend that you watch those because they develop some of the essential strategies that you probably would need to know when approaching an SAT math question. And I really recommend that you watch those if you haven't already. But yeah, let's go ahead and get started. So the first thing we're going to go into is absolute value. And absolute value is basically, this just represents the difference from 0 that something is. So if I said the absolute value of 8, of negative 8, for example, that would be 8 because it's the distance from 0. So if I draw a number line, right, here's 0, here's negative 8, the distance can never be negative, is 8 units. And if I did 8 on this end, the absolute value positive 8, well, the difference is also 8. All right, so that is just what absolute value means if you didn't know already, and if you did, then good job. All right, so on the SAT math section, you'll probably see a question with an absolute value inequality, and it looks something like this. If the absolute value of x minus the midpoint is less than the variance. Okay, so the midpoint is just the middle of two values in a data set. Like if they give you a range of numbers from like 7 to 19, for example, the midpoint is just the average of these two endpoints. So that is 7 plus 19 over 2, which is 26 over 2, which is 13. So that would tell me that the midpoint is 13. And this is less than the variance. So the variance is just the absolute value of the midpoint minus one of the endpoints. So if I picked 7, because it's easy for me to do that, I would do 13 minus 7, and I would get 6. And that is the value of the variance. So 13 minus 7 is 6. So I'll put that there. And if you can check it with any number. For example, if I plugged in 20, which is out of this range that I made up, 20 minus 13 is 7, and 7 is not less than 6. And if I plugged in 6, for example, 6 minus 13 is negative 7. Absolute value of negative 7 is 7, and 7 is not less than 6. So that is how you set up an absolute value inequality. And let's practice with a question. So first, John is running a marathon race, and each day he runs between 5 and 21 miles. The possible distances he can run in miles are shown with x being a solution to the equation below, and c and d are constants. And the question is asking us what the value of c plus d is. So here's how the equation looks like. It's kind of familiar because we already talked about it. X minus c is less than d. So we can identify that c is the midpoint and d is the variance. All right. So let's first solve for c because that's probably the first step that we want to do. So the midpoint is just the average of the two endpoints. That's 26 over 2, which is 13. We already did that. Okay, so c is 13. And now is where it gets different. The variance. The variance is, like I said earlier, the absolute value of the midpoint minus one of the endpoints. So if I choose a lesser one, for example, if I chose 5, and the midpoint is 13, 13 minus 5, absolute value of that, equals 8. All right, so that is our variance, and that kind of gives us D, which is the variance. So 13 plus 8 is what the question is asking us, C plus D. So 13 plus 8, and the answer is 21. So I'd bubble that and then move on. All right, so that's absolute value, and now we're going to go into direct and inverse variation. So direct variation means that something changes directly with something else. So if I said A varies directly B, then I would write like this. And this symbol just means that it changes at a rate or is proportional to this value on the other side of the expression. So if this is direct variation, which this is what this means, then I would write a ratio. So a value A1 over B1 equals A2 over B2. So you've probably seen this in your chemistry class, or if you haven't already, this is a very common example of direct variation, but pressure is directly related to the temperature. If everything else is constant in the ideal gas law, you don't need to worry about that. But Typically, if the volume is kept constant, and so are the number of particles of a gas, then pressure is directly related to the temperature. So I would write a ratio like this. So the pressure at the beginning over the temperature at the beginning equals the pressure at the end over the temperature at the end. So that's a common example of that. Next up, inverse variation. This means that A is varying is proportional to 1 over B. So that means as, say, B increases, then as 1 over a big number is actually closer to 0, so that means A decreases. And a graph of this will look like something like that. That's an inverse function graph. Okay, so let's practice. Actually, before I go into the practice problem, I want to show you how I would solve that problem. And I would write a product. So A1, B1 equals A2, B2. And I could solve for any of the values if they give me 3 of the other values. All right, so let's dive into a practice problem. The time it takes to build a fence is inversely proportional. Now, inversely proportional tells me that this is going to be an inverse variation question. And it's inversely proportional to the number of people building. If 5 workers need 4 hours to build a fence, the question is asking me how many hours would it take 8 workers to build the same fence? So now that we know it's inverse variation, let's go ahead and pull up the same question, the same formula that we already talked about earlier. Okay, now let's set A to the number of workers and B to the amount of time it takes. And I'll just write that here for cohesiveness. Okay, so now that we have set and defined some variables, now we can go ahead and solve for what the value of B2 is. So say A1 is 5 workers for 4 hours, 5 times 4, equals A2, which is 8 workers, times B2. We don't know that yet. That's what we're trying to solve for. All right, now this is simple algebra. 5 times 4 over 8 equals B2. This is 20 over 8. And simplifying that down, dividing by 4 in the numerator, and the denominator gets us 5 over 2. So B2 is 5 over 2 hours. That kind of makes sense, right? If you had 5 workers and they took 4 hours to build a fence, if I had 8 workers, which is more than 5 workers, I had more hands working on the fence, it should take me less time to build that same fence. And we can see that 5 over 2 is 2.5, which is less than 4. So it seems like we did the right thing. All right. So thanks so much for watching this video, and if you have any questions, please leave them down in the comments and I'll respond to them as soon as I can. Thanks again, and have a great rest of your day.